Not say any inappropriate stuff or anything like that. Okay. So what I just did, I just drew a line that goes through these 2 points, 1 and 3, and 3 and -3. So the first question here is how would we find the slope when we only have the 2 points there? So we're looking for the slope here. Can anybody remember how to find?
Y equals mx plus b.
That would be the slope-intercept form. So but we're talking about just the slope itself. Well, remember, I mean, technically remember that it's, I guess, rise over run, but how would we put that into a formula if any of you guys can remember?
I don't know.
So remember that the formula was y2 minus y1, x2 minus x1. Okay, so the difference going up versus divided by the difference going to the side. Okay, so let's start off by labeling the points and saying, okay, we have x1, y1, we have x2, y2. Okay, so what should our formula look like? If we plug in the points into the formula, what would this look like?
Oh, 3 minus 1. No. -3 minus 3.
Okay, -3 minus 3 over?
-3 minus 1.
No, 3 minus 1.
Right. So
Same thing.
not necessarily though. So we're gonna take
The top would be 6.
y2
6
and
and
y1
2.
and x2 and x1.
6 and 2, right?
So -6 and 2.
So
yes, -3 minus
-3.
-3 minus 3 is -6, and 3 minus 1 is 2. So -6 divided by 2 would be -3. So our slope here is -3. Okay. And again, this is just review from last year.
Oh.
Okay. So we found the slope.
Okay.
And I'm gonna erase, let me erase this. So our slope is -3. Now I want a line that is parallel to this and goes through points -3 and -4. So this is where we would use our point slope formula. So y minus y1 is equal to -3, or sorry, not -3. I'm already plugging in numbers there, but it should be m, which is our slope, and then x minus x1. Okay, so how would this formula look like?
Wouldn't your m be -3?
Right. So that's a good start.
X minus -4?
It should actually be x minus -3. Okay.
Why -3 again?
Because our x value is this right here, -3.
Oh, we did this last year.
And yesterday.
You just said it's a review over last year.
Oh, yesterday I wasn't paying attention.
What the hell?
He
Shut
just
up.
said it in this one, Gordo.
What the? Oh, you glad they're recording now to be?
Okay, so it should be x minus -3, and then on the other side we have y minus -4. Okay, so let's solve this. Remember, this becomes a positive, this becomes a positive, so that should be y plus 4, and then x plus 3. So we're going to take this and we're going to distribute that -3. So it should be -3x, and -3 times +3 is -9. And so what do we do to leave the y by itself?
Put the negative -4 on both sides.
So we're going to subtract 4 on both sides. That cancels out, and we're left with y is equal to negative 3x. And then negative 9 minus 14, which would give us
13.
negative 13, yes. Good. So that's just a different way of the same problem being represented, okay? All right, so pretty good. Here's the next thing, guys. Let's make sure we have that down.
Got it.
Hold on, y equals negative 3x. Okay.
I got it.
All right. So okay. So the next thing that we should do is say we're going into perpendicular lines now. So we did parallel and we did perpendicular. So what are lines that are perpendicular? What does that mean?
Lines that intersect.
Lines that intersect. So that's definitely the first thing. But there's another important part to this. They intersect. But there's another really important.
You always have an angle, right? I forgot what it is. 180 degrees?
Actually, a 90-degree angle.
90. I was going to say that, but I forgot which one.
All right, that's good though. So it crosses, they intersect, like Lajani said, they intersect. But what the other most important thing is that they create a 90-degree angle. Okay, so parallel lines have to have the same slope. But what about perpendicular lines?
They don't. Wait, do they? Because it has like 4, right?
What do you mean by 4?
Like where intercepts at?
Well,
like middle.
There is, yeah, you're right. I mean, I see what you're saying. There is 4 angles there, but that's not what we're looking for. We're looking for what do the slope of these lines need to do to be able to be perpendicular?
Not overlap. Maybe.
So let's think about yesterday. The slopes had to be the same to be parallel y. So if we think about yesterday, parallel lines have to have the same slope. So they had to look like this. Oh my gosh. There. So we had a line going like this, and we had a line going like this.
Oh wait, I remember. Hold up.
So this was parallel lines. This was from yesterday. So why did parallel lines have to go in the same direction, or like, why do they have to have the same slope?
Because they're parallel.
Because
there's parallel,
they're
but
supposed to be equal to each other, right?
they're what?
Oh no, I forgot. Hold on. I don't know.
Because I don't know. Yeah, no.
So our slope is what dictates the direction that our line is going to go in. Okay. So if our line is going the exact same direction, then we can assume that those lines are never going to touch, right? Because two things going straight in the same direction should never meet. And that's why I was saying, think of traffic, right? Traffic, you want it to be going in the same direction. If not, we get a car crash, right? So what about perpendicular lines though? We obviously want them to intersect. So what do you think the slopes have to do so that they intersect?
They got to meet.
They got to
Parallel.
meet. How do we make them meet?
I don't know.
Not too sure. Okay. So let's look at it this way. Let's look at it this way. The blue line, is it positive or negative?
Positive.
It's positive, right? So what about the green line?
Negative.
It's negative. So that's the first thing that we need to know is that we're going to do the opposite, where it's going to be either be a positive or a negative, right? Now, the other thing is that it needs to change directions so that they intersect, okay? So this is what it would look like.
M equals -1/m.
So what would happen is that we would make it a negative and it goes under a 1 to make it into a fraction, okay? So let's look at it the opposite way. What if we had 1/m? What do you think the line has to do to be perpendicular?
Negative m.
Negative m, that's right. Good. And of course, this works the opposite way as well. Like let's say I had negative m. What would my perpendicular line be?
1/m.
1/m and a positive 1/m. And if we had negative 1/m, then our perpendicular line has to be positive.
Positive.
Okay, that makes sense?
Wait, negative 1m equals m, 1m equals negative m. One and negative 1m equals m.
Okay. So as an example, let's say we had the line y equals 4x plus 3. Now we want a perpendicular line that passes through the point 3 and 2. Okay? So what is our slope here?
Your slope is, wait,
3?
yeah, it would be 3, right?
That's a y-intercept.
Oh,
So
then
it'd be
4.
4?
It has to be, yes, the number in front of the x is the slope. So that's 4.
Oh, yeah. Okay.
Now, the question is, we want a perpendicular line, so what would be the slope of our perpendicular line?
4/1 or 1/4, right?
1/4. 1/4. But one more important thing that we're missing there,
The m.
Negative.
not the m, but it has to be a negative.
Negative. Why negative? Why is that?
So remember, it always has to, perpendicular lines, one of them is going to be positive, one of them is going to be negative, right? So
Yeah.
to be able to change directions, we have to make one of them either negative, or it has to go from positive to negative, or from negative to positive. So
For it to change, it has to be positive to negative or negative to positive.
exactly. Remember the rule that we just, up here in the upper right corner, our m turns into -1/m. So that's the same thing that happens here. Our 4 turns into -1/4.
Okay.
Okay. So now that we know the slope that we need, let's put in our formula. Y minus 2 is equal to -1/4 x minus 3. All right, so we want to simplify this. And it's basically always the same steps, right? We first want to distribute. That gives us y minus 2 is equal to -1/4x. And -1/4 times -3 would actually give us positive 3/4. Okay. So now, here, let me just rewrite this just so, let me clear this because I'm running out of space. So let me just rewrite this. Y minus 2 should be equal to negative 1/4 x plus 3/4. Okay, so now we want to leave that y by itself. So we are going to add 2. So this cancels out and we have negative 1/4x. Then we're going to add 2 fractions, right? So 3/4. 3/4 and 2, right? So, okay, so 3/4 and 2. How do we add those two together?
What'd you say, Rod?
Would it be like 4/4?
Would it be 2 3/4 or something? Or wouldn't you add a 1 at the bottom of the 2?
So let's see. We kind of worked on this at the beginning, but 3/4 plus 2, right? So yeah, let's say that we have a 1 on the bottom. Okay. So what we can do here, we're gonna apply this, so we can say 1 times 3. Oh my gosh, 1 second. I accidentally erased that. So let's do 1 times 3. That should be 3. Then 4 times 2, which is 8. And on the bottom, 4 times 1. So 4 times 1 is 4. And then what's 3 plus 8?
$11.
11.
Okay, so 11/4.
Wait.
All right, hold on. Let me put it back up. All right, so yeah, that's what 3/4 plus 2 would be. Okay, so this goes over here. That should be plus 11/4. And that's our answer. Okay,
Got it.
so, okay, good there?
Mm-hmm.
Okay. So far, let's see. We've gone over through the parallel, the perpendicular lines. Tomorrow we're still gonna go over this.